hitting record. Welcome to the February 23rd meeting of the Kubernetes IoT Edge Working Group. For today's meeting, we have on the agenda a presentation on Red Hat's recently announced MicroShift project, which is a solution for running workloads at the edge. And specifically, the speaker, Miguel, that we have today is going to address using this for AI use cases. So with that said, I'll turn it over to Miguel.
Thank you, Steve, and thank you for having me. So yes, as I was saying to Steve, my plan was to play a video of the presentation that we had for DevCon because I thought it was nice. I mean, we did some technical demo of running an AI workload on the edge. But let's see if that works. If it doesn't, then I will fall back to just slides and yeah, and maybe I can. I don't hear you now. Sorry, the technical.
I know you intend to go into AI use cases, but I know for myself, I'm not all that familiar with MicroShift other than reading a couple of blogs and poking around a bit on the GitHub source code site. But if you could start with an intro to, what MicroShift is, kind of why the project was done, that kind of stuff before we get into AI, I think it'd be useful.
Yeah, it makes sense. I think that's part of the presentation. So maybe I think I will better go through the slides because then I think it's more interactive.
Okay, sounds great.
Yeah, the video in the end, it's on YouTube. Anybody can watch it if it looks interesting. So, okay, let me share screen regularly. Okay, give me a second. It's been the first time I've been using Zoom in a while. Okay, and it's asking me for permission. I need to reconnect, but just a second. Sorry about that.
Okay, gotcha. Hey, while we're waiting, Dion, I know that you were working on that report for the steering committee and shared a document. So I just wanted to bring up that all the users of this group are welcome to add whatever comments they'd like to have go to steering. Yeah, if you've got any feedback on this group, good or bad, we're open to your comments and encouraging them, and we'll, as long as they don't violate the code of conduct, I think we'll forward them into the report to steering completely unedited.
Oh, sorry, Steve. Now it says that
you need to make him a co-host again. Yeah.
Oh, gotcha.
Sorry about that.
Okay, you should be good.
Thank you. Excellent. Okay, share screen. I hope you can see it.
Yes, we can see it. It looks good.
Okay,
awesome.
So, this is me and my colleague Ricardo, who worked on this presentation. I can share the link with you later. So yeah, I will skip the EA, that part, and we can get into MicroShift. So MicroShift is a small form factor for OpenShift. We have reduced the footprint while still retaining some of the features native to OpenShift. So people running workloads on OpenShift, they can still use some of the additional security features and yeah, other APIs embedded in OpenShift. So as you know, OpenShift has a lot of operators to make everything work, and in MicroShift, there is no operator. It's a simple setup that you can customize. We use a few images from OpenShift to install the OKD distribution, and for the Intel platform, those are the same images. We don't need to recompile anything, but for other platforms like ARM, RISC, PowerPC, and so on, we recompile those images. The ARM64, yeah, those are I think they will have them on the next OKD versions. But yeah, now we recompile those images. So the idea is taking MicroShift and the way that Red Hat works on building images and building OS3 images and being able to put all that together for the edge. So yeah, we are trying to have a complete workflow for how devices are deployed on the edge, because as you know, it's not the same as the cloud or a regular data center in some cases, and we are working to put together things like the OS3 as we use in OpenShift with Fedora CoreOS. Sorry, I was ready for the video, but I didn't rehearse, so sorry about that.
You're doing fine. So in this slide, I see the secure device onboard, which we've had a speaker on. That's the LF Edge project for onboarding edge devices. Is that right?
Yes. So we are working on having all the pieces and the gaps together, and making sure that those can be used with MicroShift. There are some things which are, still not close and not clear, like the final steps on this side. But the idea is that, if you know secure device on board, you can have the manufacturer pre-initialize the device for you and have a voucher, and then you get the voucher when you finally ship the device to the final location, to the final owner, and then they can onboard the device and maybe flash the final image or update the image with the final workload. And in our case, we are working for that to be MicroShift. So you could go and onboard that device with an operating system that has MicroShift, and additionally the container. Maybe you could even put the container images of the final application, maybe on a specific version, of course. But if the device, for example, is not going to have network access and after the onboard, you could still do that. And depend, for example, instead on pulling images, you could depend on simply updating the OS3 operating system image, which is supposed to be atomic. So yeah, that if you have questions, yeah, please feel free to interrupt me. Yeah, well, after that, yeah, I don't know if you have any other questions about the idea of MicroShift. I think that's that's mostly it. So do you want me to go over the AI use case or?
Yeah, that would be great.
Okay. So yeah, and this for this specific presentation, what we wanted to do was demo a possible use case of this type of technology on the edge, and so we deployed MicroShift on an ARM device and NVIDIA, I think it was NVIDIA Jetson TX2, and we created an access point from inside MicroShift, so it was connecting to the pod network, but that was mostly for demonstration purposes. You could have an access point outside of MicroShift, but we thought it was a good example of having an operating system image with MicroShift, and then without modification of that image, you can create an access point just by plugging a compatible radio device. So here we had 4 cameras connecting to this access point, and then connecting to a service that was running inside the MicroShift cluster that had 2 models, one for face detection and another one for face recognition, and then a set of a database of faces. So yeah, those were the cameras, and they did some TX2 board. So we made an image for like the base libraries and a very simple face recognition Python library based on dlib. You have the links to that, and then the application, which the source code is also on that repository. So that image simply keeps waiting for cameras to register into an API endpoint with a token, and then the service will connect to the cameras and start streaming video out of the cameras and running the algorithms. So we also have, this is the container for the Wi-Fi access point that the cameras connect to. And yeah, at this point, we had the demo on the video. I don't know if I can play at least that part, or let me try. Let's see if that works. A second. Okay. Can you see the video on the screen?
Yes, it's a little choppy, but yeah, I could see it.
Okay.
It comes with a Linux for Tegra operating system. We haven't changed. So now we're ready for the demo. We have our Jetson TX2 board here with a Wi-Fi USB stick, which is going to be used by the cameras to connect to MicroShift and the AI workload that we created. We also have the ESP32 cameras around the office. We have one here, another one here. We have Ricardo in the corner. We have another one for the coffee machine. And we also have a completely wireless one here on the presentation table. Okay, so we are connecting to the Jetson EX2 board. And at this point, we have our MicroShift kubeconfig ready. This is created by MicroShift. And we can see the MicroShift service pods running. But there are no workloads in our default namespace. So I will start by creating the Wi-Fi access point. Oops. Apply. You can see the camera's access point. Trying to start, like sometimes fail because it's trying to reuse the HTTP server port, but now it's still the up. Let's check the logs. Okay, so the access point is running as a pod, and the cameras are connecting to this access point, and they are at this point trying to find our MicroShift application. So we look at the Wi-Fi adapter. We will find them asking via MDNS for our MicroShift registry, but nobody is responding because there is no application for that. So the next thing that we are going to do is starting our camera service. Service starting now, and we are also going to expose this service. Okay, that command. So we are going to expose this service with an OpenShift route with this hostname, MicroShift camrec local, so the cameras can find our application. At this point, the cameras are probably resolving the name, and if we look at the logs of our server, so the cameras have connected, and the service is already processing the camera feeds. We can open the video feed now on the browser. Okay. And mask off, or if we see Ricardo wandering around the office, the cameras will detect Ricardo in different locations.
Yeah, I can share the link to the whole video later. As you see, I mean, in this presentation, we didn't have the. Let me stop sharing. Is it still sharing, or did it stop?
Yes, we can still hear you.
Okay. No, sorry. I was trying to stop the share. I'm not used to Zoom. So yeah, I don't want to take more time in that. So as you saw on that presentation, we didn't go through the whole life cycle of managing workloads on the edge, which probably it's important to this group. So I'm not familiar with the topics that you normally discuss, but I suspect that those would be interesting to us.
I had a few questions. One about the demo. Were those cameras pre-configured to look for a particular host name on the network, and that's how they got connected, or did it go the other direction where they got discovered?
Let me. It was like so the cameras are looking for the endpoint of the.
Okay, gotcha.
And they register, and then the server will connect back to the cameras with a token that the camera has. I mean, you could do it the other way around. I mean, it was simpler to program for the demo, but technically you could have the camera connect and then stream video into the server, or the server find the cameras and then connect to.
I was just asking because we've had talks in this group on other technology for device discovery going the other way, like ACRI. And I suspect that you could probably put those two together and get it to work. But, it did look interesting. The other questions I had were about MicroShift itself, like, if it gets installed by a device that gets shipped out to an edge site, I saw in the GitHub registry that it says the binary is 150 megabytes. Is that pretty much all that you'd have to send over the wire to provision a device, or is that on top of an OS that you'd have to get down first?
No, I mean, you need the you need the OS, you need MicroShift, and then there are a few container images that we use. Our plan, and we are working on that, is using the OS3 technology that you can see in Rails for Edge or Fedora IoT to build images of the operating system that contain the operating system, MicroShift, any images that MicroShift will need for that specific version, and then the final owner of that will run an application inside. They could provide the deployment configuration, so that's picked up when the system boots, and it's going to make sure that the deployment is running and ready. But they could also include their own images on the operating system, so they could reveal the image of the whole thing and have it. So, and those are the things, I mean, that we want to analyze. Like, for example, on manufacturing, you could have an operating system image that has the basic operating system with MicroShift almost ready, or MicroShift plus the basic MicroShift images, but no user application. And then when you onboard that on the final destination, the additional layer of the operating system with the final images and the configuration is added. And then that's what needs to be transmitted over the wire to the device. So yeah, we are looking at all the possibilities, and yeah, there are many very important factors on the edge. Like maybe you don't have good network access, and you cannot download a lot of data.
So is it fair to say MicroShift attempted to take on the mission of just being a compliant Kubernetes with a small binary, and it really is just that, so that if you wanted other features like, I don't know, device discovery or remote federated management of multiple clusters, that you would add it on just like any other Kubernetes? Is that, that's sort of what I'm picking up here, but maybe I'm missing something.
Yeah, I'm not sure if I'm understanding the question. I don't know if Ricardo, he's on the call also.
Ricardo, I think you're muted. No, we still can't hear you.
No?
Now,
it's
yes.
getting better.
Yeah.
Sorry, I arrived late. So if your question is basically that if MicroShift is just a Kubernetes, that's more or less right, I would say.
Okay, so, yeah, that was my question. And I only asked because there are a few other edge optimized Kubernetes that attempted to bundle in more functionality. So that, I mean, that could be good or bad. You know, there's an argument against being a monolith that lets people plug and play components just the way they'd want to. And in the end, as long as you can put in what you need and get the functions you want, you're fine. But yeah, that was my question.
Yeah, we try to provide also some extra APIs from OpenShift. So developers that use OpenShift, like in the cloud and so on, can have their application some kind of portable to the edge. So just like develop once and run it everywhere. But yeah, MicroShift is mainly an edge optimized Kubernetes distribution. That's right.
Is it constrained to have a single node cluster, or can you go the Kubernetes route of deploying a 3-node cluster or something like that?
So far, it's just single node, but actually, right now in the repo, there's a PR, and we are working on multi-node. But yeah, I don't know when it will be somehow ready.
It could be with typical edge resource that single node is fine given what you might have there, but I was just curious.
Yeah, like it probably in most cases it will be fine. But for example, if your application is doing some sort of artificial intelligence workload, maybe the GPU on a single board is not enough, and maybe you need to add more, or whatever your application needs to do, it spreads over multiple places. So yeah, it's something that that we are working on, and the main delay is that we're trying to make sure that that conforms to the way of doing things in OpenShift. So we are trying to do things as close as possible as OpenShift does that today, and also trying to look at how to make it as secure as possible on the edge. Like, for example, working with TPMs to establish trust between the devices so they can connect together, or being able to do that kind of extra security that you may need on an edge application.
So how opinionated is it with regard to the operating system it runs on? I mean, obviously I understand that being done by Red Hat, you're going to support Red Hat flavors of OSs first. But if I had something, I don't know, like in my home lab to play around with, I've got Raspberry Pis, which seem to be better supported with the Debian variants of OSs from my experiences. There enough there that I could find in the documentation a way to run it, or is it at this stage pretty much expecting a Red Hat OS?
So initially we started with, with an installer that will run you in almost any distribution. But today we are going more into trying to make it, for Red Hat, for the Red Hat operating systems. Mostly because we want to develop on that idea of the end-to-end life cycle of the application, and that, most of that relies on the very particular view of the OS3 layering of the file system that they use in Atomic or CoreOS. I'm mixing all the projects at this point, CoreOS and Fedora IoT, for example.
Yeah, but if you have like a Raspbian running, you could use the container image and run MicroShift on Docker, for example.
Okay, yeah, because I heard you say that the two packaging options were RPMs and Docker images or OCI images, I assume.
Right. Yeah.
Just a clarifying question: is MicroShift one binary that's on each node, or is it containerized? So is it kind of like the K3S approach of a single binary, or are there those components, like is your control plane separated into its own pod?
So it is a single binary for most of the Kubernetes components and OpenShift control plane components. But we run as static pods or scheduled pods some extra services like ingress, service certificates, our Flannel CNI, and I think we run DNS. We run these extra services as pods. The core is just a single binary. The thing is that we have packaged it in two different forms: an RPM that gets extracted as a single binary that you run it, and then you get this extra services running containerized, and a container image that contains the MicroShift binary.
Yeah, so, and I mean it's similar to K3s, but with some different design decisions. For example, we don't embed CRI-O, and so you need to install CRI-O on the host, and yeah, then we put all the specific OpenShift services inside.
Was that decision to not embed CRI-O just so you'd have flexibility, or did something else enter into that?
I was not around when that decision was made. I suspect, I don't know, maybe Ricardo is more aware of that. I just joined the team very recently.
Yeah, our first vision was to have MicroShift. So these edge optimized operating systems like Fedora IoT or Rails for Edge, or they use OS3, RPM OS3, right? And most of the file system is read-only, and you cannot just like, edit some of the files that are embedded into this OS3. So it's like an immutable tree with packages and so on. So our initial idea was to have CRI-O embedded in the OS3 and MicroShift as a container running on Docker. So the idea with this is that you can upgrade MicroShift without interruption for the workloads. So you have these extra services running as containers in CRI-O, and you have your workloads and your applications and so on. So you could easily replace MicroShift without any service interruptions for the workload. So the idea of not embedding CRI-O is that if you upgrade MicroShift with CRI-O in it, there will be some service interruption. So that was like the initial idea.
Okay, thanks. I was just curious, and sounds like a good reasoning. Does anybody else have any questions? I've got one more, but I don't want to monopolize it here. And Wayne, I see you here. I think you're maybe a first time to this group. I haven't seen you before.
No, it's my second time, or third time, I think. Yeah.
Well, my question was just, I saw the GitHub repository, but if people wanted to get involved, maybe, like I said, for my own education, I don't have one of the Jetson things that I saw you use in your demo, but I do have some other things. So I'd probably want to take it onto a Raspberry Pi or something like that. Where can I go? Is there a collection of or a community formed where people who are using this get together and chat and ask questions and things?
Oh, we have sorry, go ahead.
No, there is a Slack organization. It's not within Kubernetes, it's just we have our own free tier MicroShift Slack, and there is, for example, a specific room for ARM enablement and how to run MicroShift on Raspberry Pis and all these kind of devices. There are a couple of blog posts from Red Hatters that have tried to, well, that have achieved to deploy MicroShift on Raspberry Pis. Regarding our demo, I bet you could run the demo on MicroShift on a Raspberry Pi, but probably you might need to do some tweaking because, of course, there are no GPUs in the Raspberry Pis. And there is a specific, correct me, Miguel, if I'm wrong, there's a specific parameter to change the machine learning model from GPU to only CPU, right? Well,
yeah, I mean, mostly. I mean, that is only part. I think that was only for the face detection. You could choose like a CPU model, but then the face recognition, I think it was relying on the CPU, but it's, I mean, technically we could reveal the image, the base image that has the face recognition and the library. So it could run completely on CPU. Slower, but it could run. And, yeah, and I mean, if you try to install Fedora on a Raspberry Pi, I recommend you to go for Fedora Minimal. There are instructions to how to install Fedora. There is a tool in Fedora itself. I think it's ARM image installer, which makes it very easy. But yeah, it should be possible.
Are there minimum device size requirements? So like, is it only work on a Raspberry Pi 4 or can work on a Raspberry Pi 2 as well?
I would say, I need to check if we are still building for ARM32. So it will need to be a 64-bit device. So on Raspberry Pi 4 for sure. On Raspberry Pi 3, I haven't tried, but technically it should run.
Like what is the minimal memory required? I think that is probably one of the determining factors, right?
2 gigs.
2 gigs.
Yeah, we recommend 2 gigs. For that demo, it was more because the models are in memory in the end, they were huge. So
right. MicroShift plus the OS components and all that is usually like 1 gigabyte. So you have one more for your applications. But
well, that sounds then like it could run on a Pi 3, which is limited to 1 gig.
Yeah.
But then your application workloads may need to be a smaller workload. Okay, that makes sense.
Yeah.
It's actually it's something like 700 megs or something like that, but still, yeah. We didn't go. I mean, we didn't explore optimization too far. At this point, we just trimmed down all the operators and everything unnecessary for that we thought is necessary for the edge, like image building or any other. I mean.
So how flexible is it for making your own choices on componentry? Like from the sounds of it, you separated out the CNI so that a user should be able to choose their own. Could they choose a container runtime other than what is built in? Maybe that's potentially on the table too, or not?
I think for the container runtime, it's only Cryo. And for the CNI, I don't know if that's modular on the settings yet, but I found that, I mean, we are installing Flannel so far because it's probably the smallest thing that we can use. But also, I mean, if you are going to be on a single node, you could use the cryo, the bridge plugin, which is going to put all the containers on a virtual network, but single node, no multi-node connectivity. So that would bring down a little bit more the disk and memory requirements. And for the other, I mean, so we have, I mean, the components, you can select some of the components and disable them. I think Ricardo worked more on that part because it was done before I arrived into the project. But there is, yeah, some work that we need to do yet to make, I mean, to be able to select granularly all the components that are installed into the system, and even, I mean, pre-configure like maybe the YAMLs with the workloads that you want to run in your device. So the system boots up and it boots to your final application with just the components that you need and nothing else.
I'm a little curious about your statement of for security, how you were planning to integrate in the TPM module that is on the device. Is that likely? Do you see that as something distribution dependent, or is that just a Kubernetes issue potentially, where you really need to get, you know, some mechanism of having a secure store with authentication encryption facilities available to Kubernetes apps?
I mean, technically, I think that part is open, and maybe, I mean, it's open, like the APIs for TPM in Linux, those are open. I'm still learning about them, but I mean, as far as I understood, you could have a private key that runs on the TPM, and you could, I mean, do your authentication like with a client certificate through the TPM, that the TPM will be signing your requests to maybe the master node or something, the device manager on your IoT network. So I think that, I mean, I haven't explored the problem completely, but I really have the feeling that that's probably a good way to go to establish trust and also have something secure, because if you have credentials on disk, anybody can open your device and encrypt, even if it's encrypted in the end. I mean, it's just a matter of time. At least on a TPM, you have something that you cannot extract. I mean, they could technically, if the TPM is not inside the processor and it's external, I suspect that they could just rip the TPM and use it to authenticate. But I mean, it makes it harder. But I think, yeah, that maybe at some point, I mean, we could have maybe a standard method to do authentication in Kubernetes with TPMs. I don't know if anybody on the group has explored on that topic, but I think it's a very interesting one.
I think I've heard of people working in that area, but I don't have personal experience. But it seems like that should be something that would be doable and useful for holding, I don't know, Kubernetes secrets and just generic storage as well.
I think it's also going to be really important for large-scale deployments, because if you're going to handle the rollout of 1,000 edge nodes, you're going to want that as your basis of identity that you can use to do less human touch onboarding, or ideally like zero touch onboarding. And I noticed in your presentation, you actually had a shout out to the secure device onboarding, or I think that's the name of the project, right, in the flow. And so the root of that, of course, is that you have to be able to trust the hardware that it comes from, right, and have some way to validate that in the process. So it seems like that was already considered, that should be in the workflow. And I think the implementation is the tricky part, right? The devil's in the details. And it is, if you solve it, then you're solving it for the whole industry. So I would say the discussion right now is a really, really big one, right? And as usual, Steve asks the pointed questions that cause really good group discussion. We happened at the Eclipse side, at the Edge Native working group, we happen to be putting together an article right now, opening the discussion on this topic, right? It's like how to use 509 certificates as a potential stack that would give you the ability to stack your identities, but it all begins with a hardware root of trust. And then the question is, how do you leverage that properly? And maybe you didn't build the device. And so then you also need to say, if we acquired it, but then we put our software stack, how do we certify ours? And anyway, I'm basically rambling, but I wanted to say that this discussion is about a 16-hour discussion in itself with no final answers. But I thought it was cool that you had the device onboarding in your flowchart.
Yeah. I mean, it's something that I've been exploring. Like in the last few weeks, I deployed like on Fedora. They were developing the Fedora IoT project. They were developing Fedora, the FIDO onboarding protocol, like the manufacturing server, rendezvous, and onboarding server, along with the application that you have to run on the device. And so I was getting all those pieces and getting familiar with them. And there are some, FIDO defines the protocol of how do you do that, and you can, you can move the device and authenticate the status of the device during the whole process. Yeah, there are still some gaps, like in my opinion. And I don't know, I would really love to join the discussions you were mentioning.
Yeah, this group had a presentation from Intel on this, that secure device onboarding, I think was to a fair extent initiated by Intel, and then they moved it into the foundation. But that presentation happened about a year ago in this group, and it's up on YouTube. So I thought it was a good presentation that covered the subject well as of that time. Now, like all things, this is a rapidly changing area. So I suspect that what might be in that presentation is potentially stale, but it was a great overview of what was in there and why you needed to care about these things. And there was a lot you needed to care about. Kilton, you apologized for rambling, but while you were talking, I appreciated the rambling. And you brought up the point of the TPM or other module being necessary to authenticate the edge device. But I think another factor in here for this and many other things being proposed for edge hosting of applications and services, they're using OCI containers, either Docker images, or some of these talks have been even on WebAssemblies potentially packaged in an OCI form factor. And at that point, your image registry also becomes another thing you need to care about. There are a lot of these scenarios where people invest in a container image registry that does security scanning and things, but if you could pull off, DNS poisoning or something so that these edge devices start pulling images from an imposter, that could be a really bad day. And if you're going to end up having a big picture support of TPMs for authentication and secure storage, it seems to me like maybe those even need to be integrated into your whole container distribution pipeline.
This is great. I completely agree. and then I'm going to add another log onto the fire. So how about those cameras? So whatever you're connecting to probably needs to be able to be certified as well as a disconnected but connected information source, right? It's not built into the board. And therefore, even if it's over I2C or SPI, it could be something that is a plugin, right? And so then how do we certify, or USB, it's USB attached, right? And so the hairball mess of certification and attestation is a wonderful playground and a great place to start a company right now. but the thing is, it would be very difficult to solve it in a universal way. So I think just open discussion is probably, my guess, is going to be going on for years. And you're right, Steve, that was a year ago that we saw that with the secure device onboarding. And I think it was good for everything it covered. And then there's probably about, a dozen more things that need to be added, such as, container registry. And then I would bring sensors or devices to the list.
Yeah, bringing devices, you're saying it's a good idea for a startup or something, but would make a great movie plot too for these kind of heist films where they go in there and patch out the security cameras in ways that are probably incredulous. But then again, when you look at this, what would stop that really? From, you think you're monitoring all your security cameras and somebody hooks in a pipe of a recorded video that isn't really what's going on.
That's right, because you can mimic a camera feed, right? Because it's the same network traffic. That's the exciting version, is the James Bond hack. Then the non-exciting version is that you go to like a weigh scale for vehicles coming through, and the equipment certificate is out of date because it has not been calibrated recently enough, or for things like fuel pumps and so on. And that's not movie worthy or exciting, but it is actually really exciting in industry, which is, you could say that the certificate lifetime is valid, aligned with the regulatory body calibration period that you're required to have it checked and certified. And then the cert expires and you can't use that sensor anymore as a valid information source because it hasn't been recently tested by the local authorities, right, or the industry experts. Some pretty cool concepts.
An interesting thing that just popped into my head for cameras, given that some of these are legacy things with long device lifetimes, meaning that people aren't likely to change them out for things with TPM chips if they were even available, there might be a way to close the loop by having a device with a TPM engage an activity that would be picked up by the camera, so that at least you'd know that it was connected end to end. Let's say I had, a laser projector that could project a pattern on the ground at a random time and verify that it comes in through the video stream. At least you'd know that at that point in time, the video feed was authentic and the camera was where it should be. You could have a laser projector or maybe a drone that flies in the area, or who knows what. I'm just daydreaming here. But
this is really cool. What you're actually talking about, Steve, you could generalize as two-factor authentication for things that exist in the physical world, sensors, et cetera. And it's kind of like, what's the source of entropy that we would expect to hear from? Same as I used to have a key fob, right, in 2005 to get into my banking system or whatever. That's really interesting. Something that would be impossible or very difficult to mimic, but would be using the sensors mode of data interpretation. So it's audio. So you would play a tone that would be like a two-factor key over the tone, and that's used to regularly authenticate the sensor.
Yeah, I think you could use
that's very James Bondy.
General technique for video, audio.
It's worthy of a patent. You should go and patent that if it's not patented.
Well,
anywhere.
it's too late. We already put it out in public, so my employer might take me out and shoot me for not giving them first bite at this apple. But
put it on the list of things I intend to file as well. That's
okay. Well, we're 1 minute from the cutoff. If anybody wants to throw in any last questions, now's the time to do it.
Just one quick question from me. So you're saying regarding it being an OpenShift in a miniature version, right? So it doesn't have operators, but does other OpenShift features comes in like routes and console and CI/CD stuff? Is that packed in? I mean, how hard would it be to migrate the application that's customized to run on OpenShift B to make it run on the MicroShift?
I'm just looking for an open PR that we have. Yeah, here it is.
I apologize, folks. I have to drop. I have a meeting starting now. So this is a great session. Thanks so much for the presentation.
Yeah, thank you for joining the comments and the questions.
Cool.
Great to meet you.
Yep, see ya.
So yeah, I will paste the PR. If I know how to do it. Yeah, and there you have a list of the included APIs and the not included ones.
Cool.
Yeah, but I mean, mostly, so we have we include the role binding restrictions, the builds, images, and proxies APIs, image registry configurations, and then cluster resource quotas and security context constraints. And then all the other ones are not included.
Yeah, and the thing is that even though MicroShift doesn't ship cluster operators, you can always install operators on top, like Tecton or whatever you need. So.
Cool, thanks.
Okay, well, we're 1 minute past the top of the hours, but thanks. That was a great presentation. I appreciate the effort.
Thank you, guys.
If you can afterward get me the link to the presentation that was in the recording, and I don't know, whatever you want to give me, I'll cut and paste it into the meeting notes so that people who catch this on the recording can find it later.
Okay, yeah, I will do. I think I can paste it on the agenda, so I will add it right away under the specific point.
Okay, well, with that said, thank you everybody for attending, and we'll have another meeting on the APEC time cycle in about 2 weeks and in the North America cycle in a month. So catch you at the next one. Bye.
Thank you for having me.
Thank you.
Yeah. Bye.